The story you are about to hear is true and heart-wrenching. We are a family of Maori origin, which also includes a variety of many mixed bloods. Our Maori heritage means a lot to us. We belong to a tribe, which is Ngāpuhi, and we also have a sub-tribe, which is called Ngāti Whātua. It all started in 1988. The year is unforgettable. Cyclone Bowler hit New Zealand around about March. That was the same time as my husband, Makutu, died. 1988 was the most horriblest years in my life. I'm not quite sure which one of the girls had their babies first. I think it was Karen. Karen lost Christopher, who was, I don't like saying deformed, or he was just not perfect.
Christopher was born in September 1988, and to actually give birth to a child that so many things wrong with him, it's really hard. I thought I was going to have a normal child, but then when he was born, and there's so many things wrong with him, and then he, passed away about an hour after he was born, was really hard to cope with. I had no idea that it was going to happen again.
I named him Lyndon, and Lyndon didn't survive at all. At birth, he died. It took a couple of months before I could even think about it, to try and get over it, and even to this day I'm not over it.
And then I got pregnant, and the same thing happened to me with William II. He was only in my world for 9 hours, but it was a good 9 hours. To me it was a long 9 hours, but yeah.
And that's when my dad, Chappie, also said that it was like a Makutu, a curse. That's when I heard it. I thought about it myself, but I didn't want to believe it. And I just brushed it aside. And then Dad said, why was it happening to him and his children, his grandchildren? What has anybody done? I was married in 1963. In those days, if you got pregnant, you had to marry the person to give the child a name. We got married in June, and I lost the baby in about September. It's very hard to describe, I suppose, that when you lose something, it's like losing your whole being. I never saw him. I didn't see Watty at all, so I've got no idea what he looked like. Unfortunately, I had 4 girls. The oldest being Phyllis, the second one is Karen, the third one is Shona, and 10 years later down the track there was Nuki Jane.
You know what, we always get together and we always just end up laughing.
I think all it is when we start missing one another, then we start turning up at Mum and Karen's.
Well, there's every day, just non-stop talking.
For some. More families need to be
We've always been a close family, even with our, cousins, first cousins and stuff like that.
Yeah.
Always been close.
We're all like brothers and sisters, our cousins and all.
As you can see, this is only 1/16 of the family. When we're all together, it took a bus.
We laugh a lot.
Yeah.
When we get together.
Yeah. That's their way of getting over things, I think. We were told by the doctors at the National Women's Hospital that it would never happen again in a million years. If you lose one, you get over it. But when you start losing 2, 3, 4, 5, 6, 7 of them, you don't think that it's ever going to happen to you that many times. No?
When I had David, he came out with a smile on his face and a glow.
He knew his mother's touch. You know, I'd be rough with him, as little as he was and as fragile as he was, but he knew it was me.
Christopher's father sort of like pointed the finger. It's like, it's all your fault.
I was still very naive, still thinking that the baby would change, still come out perfect.
This is something that I wanted to treasure while I had him, because I knew I was going to lose him. Then when Philly and then Nuki, it's like, whoa, there's something up here. There's definitely something up. But we had no idea what.
Oh, I was starting to worry, what is wrong with us? What's happening to us? Why is it happening to us? What have we done wrong,
It wasn't until my grandfather said a particular word, Makutu. I was like, oh, I know what that word means. That's not good.
Makutu is something that if you wanted to do something bad back to me, you would put this Makutu on me and say, well, I would like her tongue to be tied up in knots. That's an example. And I would send it back, but not to you. I would send it to the weakest of your family or a child, because that's where everything hits home. For the love of me, just didn't think that it was Makutu. I didn't have that feeling. I think if I did have that feeling, I think things could have got out of control. Then Stephen came on the scene. Professor Stephen Robertson.
Go. Oh, she's the queen.
Watch out for the top.
Hold on tight. Yay!
At the time I had met June and her family, several of those boys had been born. No one had a firm diagnosis for them. My initial approach was couched very much in the terms that I would like to sort of try to find first a diagnosis and then perhaps pursue the possibility of finding an answer.
Finally, somebody was going to do something about it. Somebody took the time out to care about what was happening to this Maori family.
Run for your life, Mark. Ready, steady.
I would describe myself, I suppose, first and foremost as a family man, really. You can't help going through life as a physician and especially as a paediatrician and not relating the experiences of the families you see with disease and disability and problems and relating that back to your own experience as a father as well. Why paediatrics? I suppose it's because kids get better, and when they get better they show joy and they get back to living life with such verve, such enthusiasm. You can't not want to deliver that for a young human being.
And how's his appetite? You're heading for a position in the front row, aren't you, Nicholas, rather than half back?
Sometimes you wonder how you would cope with the sorts of challenges you see other people negotiating, and you take quite some inspiration from what you see from your fellow human beings. The importance of what I do is divided into both being a physician and caring for people with disability and disease, and at the same time having the privilege to be able to explore those questions scientifically. That's one of the great joys of what I do.
I think Stephen came on board about 96. At the beginning I thought it was going to be real scary stuff, and why should we have to give out all this information? This is what was running in my head.
All I can remember about it is he wanted to look at our toes and our fingers. Yeah. And we wanted to take our shoes and socks off. So, yeah.
These little boys died because their skeleton was imperfectly formed. Their chest was too small. Their limbs were twisted. They had pieces missing. In meeting with June's family and examining her daughters, I wondered whether there might be subtle signs in the skeleton which might give me some indication as to their carrier status.
He just made you feel so comfortable, so relaxed, that you just wanted to tell him about your whole life, but he only wanted to know of certain things.
What we figured is that this family clearly had some kind of damaged gene that was carried down generations, carried silently by women, but seriously affecting males. To even begin to hope we could actually find the single gene fault in the genetic constitution of this family seemed to be a little bit of a dream. What drew me to the genetics? I think the fascination of it primarily. All the bits and pieces of what brings a human being about, what makes them grow the way they do, and how it goes wrong. In many ways, geographically, we've charted our world pretty well, but what are the mysteries that still lie around us? And one of them surely is how we get from being one cell big to being billions of cells big, and the complex, and I think engaging organisms we are. That's what I've chosen to scientifically pursue. Not just driven from that fascination, but actually having the added benefit of pursuing questions about disease for families that are afflicted by them.
My hopes, to tell you the truth, was that there wasn't any chromosomes, no affected genes, nothing. I just wanted it to be something totally different that could be fixed.
I think it would have been easy for them to say, no, I distrust this. This is research we've been almost experimented upon as a curiosity. But I think, as is true to their sort of spirit as people, as I've come to sort of get to know them, they decided that no, that's not the approach to life to take. This is an opportunity which could not only help us but help others. And they said that right from the start. Not just them, but also others. What leaps out when you meet a big family with a lethal disorder is that there must be something very special running through almost the life force of a family like that, that even something like this will not derail further generations, that the whakapapa will not stop, that this thing can be lived with and life will go on. The condition's called oto-palatodigital syndrome, which is a very cumbersome medical name.
In looking at June's family tree and wondering where this genetic condition started, the obvious person to think hard about was June herself. That there must have been some kind of change in her genetic blueprint right at her conception, which led to this disorder.
Why these genetic changes happen in our constitution is still a little bit of a mystery. I think the most explainable mechanism by which they occur is just one of simple chance. Our genetic constitution needs to be replicated faithfully every time a cell divides in our body. You're changing 3 billion letters in a DNA code billions of times, and mistakes happen, and that's when mutations occur. The beginning point with June's family was knowing that their condition is what we termed inherited in an X-linked manner, which actually means that the physical location within the cell of this gene is on a body called the X chromosome. Now, chromosomes are sort of the physical embodiments of our genetic constitution. When you look down a microscope, you can see these things. There are 23 of them, and they come in pairs, and the X chromosome is one of them. And the X chromosome is special because it's different between males and females. It's paired with a Y in males, and there's only 2 X's with the female, no Y. When you inherit something that's defective on the X chromosome, you're very susceptible as a male. You only have an unpaired X and a Y which doesn't actually help you in compensating for that defect.
But a female does. A female has 2 X's, so the second one can back up a defect on the first. And that explains why in June's family the females get away without any serious manifestations of this disorder by and large, and it's the males which get the severe disease. But it's not all the boys that get this disorder. It's a 50-50 chance, a flip of the coin. The female has a faulty chromosome and a non-faulty chromosome. So a female has a 50% chance of producing an affected son, if they're going to bear a son, or a 50% chance of producing a carrier daughter, if they're going to produce a daughter. In June's case, every time she conceived a daughter, that individual turned out to be a carrier, just by chance. Fortunately, some of them have been lucky enough to have healthy sons.
Boys in our family, they are precious in their own way because there's not very many of them.
My immediate family is my son, William. I love that kid. Yeah. He's come a long way. Anything was to happen to him, I don't know what would happen, you know. He's my world. I wanted to live on a farm and, you know, have a whole lot of kids running around. Yeah. That didn't happen. Joshua, when he was born, his birth and death was very different because he came into this world and stayed with us for 10 days, you know, and the first time I heard him cry at the hospital was like a little kitten meowing, you know, and that sort of broke my heart. And that was the first time we've ever heard one of our boys cry. First time ever. So, yeah. He was a very special angel, that guy. Just tiny, you know. It felt I had to bring my arms up a bit closer because he was so tiny. He was only 3 pounds of butter. You know, that's how big he was. When he lived for those 10 days, I thought he was going to make it, you know. 10 days was like a lifetime. I wanted more, I really did, but I didn't want to go through that again. You know, how many do I have to bury before I can have a normal childbirth or a normal child?
While we were working on this condition, children were added to that family and affected boys were born and died. It really sort of hit home that life was going on for that family. We needed an answer, and that's where a lot of the motivation came from. We'd found this incredible clue that told us a rather localised part of this X chromosome housed our answer, and I spent all my years in Melbourne working very hard looking at that part of the chromosome, guessing and wondering where it might be. It does enter into your mind that, oh gosh, you might be so lucky as to actually find the thing. Professor Andrew Wilkie was someone I only knew by name when the whole issue came up that we should try and engage a good scientist. Andrew was one of the very best researching physician scientists in clinical genetics in the world. His colleagues jokingly refer to him sometimes as the brain of Britain.
The first I heard from Stephen was a fax which mentioned that he'd got this family with a condition and he was looking for someone to do a little bit of genetic work on it. I thought this looked like a couple of weeks' work. So little did I know that 5 years later Steve himself would be in the lab to work on this himself.
When the opportunity to go overseas to Oxford came, and Andrew was very keen for me to go. It was a dream come true. So I remember the day I pitched up here to the front door and saw it for the first time, and it was exciting, yeah. To come here and to meet with people like Andrew Wilkie and to work with them, some of the best scientists in the world in molecular medicine, was a real thrill. How big was the magnitude of the task? We were potentially looking for a single misspelling, a single drop of a letter in the genetic code. If you sort of think of our genetic constitution as an encyclopedia set, it's got all the knowledge and instructions that you require to make a human being within it. And there are 23 volumes, as in 23 chromosomes. We didn't have to bother with 22 of those volumes. We knew the X chromosome must have the answer, but it's still a very thick volume. And we need to find not only the chapter, not only the page, but we need to find a spelling mistake on that page. And so that's the challenge, finding a spelling mistake in a very thick book. We were looking for a needle in a haystack. And at the same time, though, it seemed with persistence and some doggedness, luck would turn our way.
The years that Stephen was in Oxford was really horrible because, to me, he wasn't close enough. Like, if anything, we needed him for an emergency, although he kept in touch with us. You know, he was always ringing up.
Inevitably, when we phoned up, there would be more than a natter, yeah. The phone bill sometimes slipped another decimal point. But they were always great conversations and extremely honest. In researching these issues for a Maori family, I had to be very sensitive to issues, not just the fact that we had some of their DNA, some of their genetic material, but also I was forever dealing with pictures of their offspring, pictures of those little boys, pictures of them.
Not once did any of the girls say, I don't want this to happen, I don't care.
When Christopher was born, they wanted to take samples from the umbilical cord, and it's like, okay, yeah, you do it, you go for it, we'll give you consent. If it means, finding things out, yeah, that's not a problem.
Sometimes I used to get nervous about, say, publishing a photograph, and I'd ring up June and I'd say, look, I know this is very sensitive, are you sure, you're happy for me? And it was always unquestioning. In the next breath, of course we are. The X chromosome is a large chromosome. It's one single molecule of DNA. It's incredibly long. DNA is made up of letters, one after the other, a bit like one long sentence. And the X chromosome sentence has over 150 million letters to it. And spread out over those letters are 1,200 genes. Some in clusters, some sparsely separated from one another. There was a 2 million letter long piece of the X chromosome we knew the answer lay within, and there are about 60 genes in there, and one of them was the gene we were after. A gene is a bit like a biological computer program. It sits by itself and it specifies a function. If there's a mistake in that program, just a missing letter or a missing code or a missing piece of punctuation, that program will stop. We were picking off a priority list of ones which could reasonably be potential candidates and excluding them one by one. We could make definitive statements about areas where the thing is not. We just hadn't found out the place where it was.
We talked about the progress he was making, and I just said to him, "You're getting any closer?" And he'd say, "Well, I thought I was, but I'm not. So I've got to start all over again."
It was a roller coaster. There were also false alarms where we thought we'd found it, or we're about to find it. But indications looked strong, and they were roller coasters too. Andrew Wilkie and I used to talk about time frames, when we would begin to sweat and when we would just maintain our nerve. As the first year ticked by and the second year ticked by, and I still hadn't nailed this thing, I used